Okay, part 2. So we're graphing radical functions. We look at this and we should think, hey, there's our new parent function. Don't know if you need another reminder of this, but if I start plugging negatives in, they just don't work. They're not part of my graph. So I know that the square root of 0 is 0, so that's the first thing that actually pops on the parent function. I picked perfect square roots just to make life easy. Square root of 1 is 1, square root of 4 is 2, square root of 9 is 3. So there's some more points. 1, 1, and then 4, 1, 2, 3, 4, 2, and then 5, 6, 7, 8, 9, 3. And you can see that this thing goes up like that. Now that's the parent function. So what does this do? Remember, that goes down 1. So I'm going to take a red pen just so it jumps out at us. We've got to take this thing and go down 1. So that goes down 1. That goes down 1. That goes down 1. Down 1. And as you can see, the graph's kind of squeezing us in here, but that's what this is. So now we can talk about the domain. Well, how far left does it go? Well, it gets to 0, and it does get there. So that's a bracket, 0, and then it just goes to the right forever and ever. Range. Well, how low does it go? Always start with that. Well, it goes down 1, and it gets there. How high does it go? Well, it takes a while, but it gets up to infinity over an infinite amount of time. Increasing or decreasing? Remember the rule. You got a little roller coaster. I'm talking about the red one, but it actually applies to the pencil too. And we have to move left to right on this curve. Is it going up or down? It's going up. Okay, let's go with this one. Well, we already know that the parent function looks like this. Ish. What does this do? This is a situation where it moves left 1. So we take this, we move it left 1, that moves left 1, and I kind of get the feel for what it kind of sort of looks like. And now we can talk, domain talk. How far left does this go? It gets to -1. Bracket. How far right? Forever. How low does it go? This one goes down to 0. It touches the x-axis, so the range starts at 0, and then that also goes up forever. It's also increasing, just like these were increasing. Alright, you guys should be really good at these. Here's my A. There's an invisible B that's a 1, so that's no change. We don't talk about that much. There's my C, there's my D. So, it says parent function. We just talked about that. They don't want us to graph it, just talk about it. What does that do? That's a vertical stretch by 2. What does an x minus 1 do? That moves it right 1. What does this do? Up 3. That's all you need to do. Hopefully you guys are getting real good at those. Now we're going to solve some radical equations. Well, remember, if we have a math problem and it's like 2x plus 3 underneath the square root, in algebra, you know, if you had time, you should always check your answers by plugging them back in. But you must check your answers because you cannot have a negative underneath the square root. So, with that being said, how do we get rid of the square root? We square it. So if you square a square root, the roots fly off. And now we've got a trinomial. Remember what our rules are. Set equal to 0. Try to keep the squared term positive. And then factor or quadratic formula, whatever your favorite choice is. So I'm going to add x, subtract 6. Add x, subtract 6. So I'm going to get 0 is x squared plus x minus 6. This is factorable. What are two factors of -6 that up to 1? That'd be +3 and -2. And so my answers, my possible answers are -3 or 2. But before we say, yep, those are our answers, we've got to take this, plug it in here. 6 minus a negative 3 would be 9. And this is a very, very strange rule, but we got to get used to it. When we plug stuff back in, remember what we said in the original lessons. If we have the square root of 100, in the back of our mind, we know the answer is plus or minus 10. But all that algebra wants is the principal root, so that's 10. It's a very strange rule. When we plug this back in, I'm going to show you right up here. We get the square root of 6 minus a negative 3. That's the same thing as 6 plus 3, which is 9. But if we put that negative 3 right there, we're not even supposed to think about this as being a possibility. We're only supposed to think about the principal root. I know that's a very strange thing to understand, but we throw that out. Throw it out. Put the 2 in. 6 minus 2 is 4. Square root of 4 is 2. That's our winner. Very strange rule in math. I'll give that to you. This one, add 2, add 2. Cubic root of x is 9. This was a lot easier than the last one. I'm going to cube this, and I'm going to cube this. This absorbs this, so we're just x equals 81 times 9 is 729. And if we plug that back in, the cubic root of 729 is 9. 9 minus 2 is 7. So, yep, check mark's good. This one. Again, a lot of people think about a situation like this. You would never do this in a situation like this, but if I squared that individually 4, square that individually 9, square that individually 25, that doesn't work. So don't square this, and square this to get started. It's not going to work. Instead, let's make our lives easier by just isolating the square root. 25 plus x equals 4. Now we can square this side and that side, and we have no problems like this. Square root, the roots fly off. Subtract 25, and I get x is negative 9. Now don't just jump to conclusions and think because your answer is negative it doesn't work. What's 25 plus negative 9? That'd be 16. Square root of 16 plus 5 is supposed to equal 9. Well, that's 4 plus 5 is 9, so guess what? That's a good answer. 24. Same thing, guys. Don't square this individually. It's just never going to work. So we got to isolate our square root, even though it's a pain. So we get 6x minus 20 equals, I'm going to write this as x minus 6. Now I'm going to square this side, and I'm going to square this side. Again, don't square things individually. Group it and square it. Group it and square it. This cancels the square root. This one, don't you dare square this and think you're doing it right. That's another trick. You got to be careful. When you square a binomial, you have to square the binomial. So be careful there. So we have to FOIL this. X times x is x squared. I'm going to go outside, inside in one swooping move. Negative 6x and negative 6x. And negative 6 is 36. Again, we've got a trinomial lurking. So those are our basic rules. Our squared term's positive, so we're not going to move anything over here. We're going to move all this stuff. And finally get 0 is x squared minus 18x plus 56. Let me pause that a second. So, Algebra 2 is kind of cranking it up a bit. So we got a 56. We've got to find the two factors of 56 that add up to negative 18. Now remember I told you quadratic formula is a possibility. If you just hate factoring, you can always go with this. But I personally go with factoring. But this one's kind of nasty. These are all the numbers that if you multiply them together, you get a positive 56. We're looking for the combination that when you multiply and make 56 and adds up to negative 18. After all these possibilities, this, believe it or not, is the magical combination. So that's a little difficult. No doubt about that. And so what are my two answers? 14 or 4. Don't forget to plug these back in. So I'm going to start with this one. I'm going to do a little math in my head. That's 84, 6 times 14. I'll show my work here. 6 times 14 is 84 minus 20 minus the original, our answer, is supposed to equal a negative 6. Now this gets kind of weird, so hang in there. This is the square root of 64, which is 8, minus 14 is negative 6, and that is true, so we're going to keep it. Now we're going to put the 4 in and see what happens. 4 times 6 is 24, minus 20, minus x is supposed to equal negative 6. Well, this gets weird, but 24 minus 20 is 4. What's the square root of 4? 2. Is 2 minus 4 equal negative 6? No. So that gets thrown to the curb. Tough little math problem. All right. This one says, solve for y. Now, I'm going to pause this a second. Possible typo, but I'm not sure. Okay, I hate to do this to you, but it's actually going to be good and educational, ACT sort of stuff. But I'm going to show you how to do this problem if this is a typo and it's supposed to be a y. Because it says solve for y. I'm pretty sure these are all supposed to be y's. It's probably a typo. So let's go with that. Then I'll show you what to do if it's not a typo. So this one right here, we're going to isolate the square root. Remember, that's your rule for these types of problems. So we get the square root of y minus 2 equals y minus 5. Now I'm going to square this side by grouping it, square that side by grouping it. Roofs fly off, and I got to take the time to go ahead and FOIL this out. So I get y squared outside inside negative 10y, and then plus 25. Now I got my world of trinomials happening. Set equal to 0, keep the squared term positive, so I'm going to move this stuff over. And so I would get 0 is y squared minus 11y plus 27. Maybe it's not a typo. Because this is not factorable, I'm thinking it's not a typo. But to solve this, now let's just keep going though. There are no two factors of 27. 9 and 3 make 12, but it doesn't make negative 11. So A is 1, B is negative 11, C is 27. So if I follow this right here, b squared minus 4ac all over 2a, put things in where they belong, I'd get 11 plus or minus 121 minus 4 times a times c all over 2a, which is 2, which is 11 plus or minus the square root of 121. That'd be 80, that'd be minus 108 all over 2, and that would be the square root of 13. So as crazy as this looks, 11 plus or minus the square root of 13 all over 2, that'd be my answer, and there's no way I'm plugging these back in to check them. That'd be absolutely crazy. So maybe it's not a typo, and they're just giving us a problem that's called abstract algebra. In other words, let's just go with what they say to do. So subtract 5, deal with the x. So I get the square root of y minus 2 equals x minus 5. Square that side. Square that side. Roofs fly off. And then I have to multiply x minus 5 times x minus 5. FOIL that out. And I'm going to get x squared outside inside minus 10x plus 25. Now I'm going to add 2, and so I'm going to have to write really small here. Y would equal x squared minus 10x plus 27. There's nothing else to do there. Nothing to really solve for. So we're done. There you go. Nope. All right, we'll finish this problem and then we'll call it good for this particular video. Story problem, don't panic, just think. The formula D equals this crazy stuff, gives the diameter D, so they're giving you a big clue. That's our diameter. In inches of a rope needed to lift a weight of W, so that's W is weight. In tons. How much weight can be lifted? That means find W with a rope that has a radius of 2 inches. Back to geometry. If that's true, then your diameter is 4 inches. So I got to put a 4 in there. And then I have the square root of 15W over 3.14. Now this is basic math. This is not under a square root. So I'm going to multiply this side by 3.14 so they cancel. I got to do the same thing over here. Just trying to isolate my radical just like we've been doing. So 4 times 3.14 is 12.56. So 12.56 equals the square root of 15W. Remember, how do we get rid of a square root? Square it. But then I got to square that side. So I'm going to take that answer, 12.56, square it, 157.8. I'm going to round it. 157.8. And square root, the roots fly off, and then one step away. Divide by 15, divide by 15. And 10.52, we'll say. So W is equal to 10.52. Remember, in tons, so that's tons. That finishes this video. Part 3 is coming. Like and subscribe. Let's go viral.